everybody, and welcome to our webinar, Holistic User Interface and Sensor Validation for Smart Products. My name is Kay, and I'm the Product Manager for Software Solutions at Magna in Munich, Germany. Today's speakers are Sören, who's the Digital Product Manager of Testbirds. Furthermore, we have Alex. He's the Business Development Manager of Magna and Bastian, he's the Group Leader for Software Solutions of Magna as well. Let's move to the next slide. You know, today more and more products rely on sensors and smart programming while being controlled over apps or intelligent human-machine interfaces. In this webinar, we want to demonstrate our approach to the validation of such products with the help of a case study, and it's about a vacuum robot. Many manufacturers of vacuum robots have the vision to take a big technological step towards fully autonomous and smart vacuum robots. The devices should be able to move around the customer's premises without additional aids. In order to ensure orientation, the robots will contain more and more sensors that need to be monitored and secured. Magna provides with Testbirds a combined solution of the recording, the analysis, the validation of sensor data, as well as automated testing and crowd testing for touch displays and app surfaces. The speakers will first explain what validation and crowd testing can do for smart products with sensors, and then they will give you an overview of how telemotive test automation and crowd testing are used within a case study. In the last part of the webinar, we will have a panel discussion where you're invited to ask any questions. When you have questions in between, we will answer them right at the beginning of the webinar. You are all muted by default and we cannot hear you, but if you have any questions, please put your questions into the chat. I will hand over to Alex.
So, hello everyone. Thank you, Kay, for the introduction, and hello from my side. Just again, shortly to introduce myself, my name is Alexander Mosen. I'm doing business development at Magna for about 4 years now. And my main topics are the TTA test automation framework, as well as engineering projects, especially in the area of test automation. So how do we want to start this webinar today? First of all, we want to introduce to you technologies that are used in modern smart products with a focus on sensors and user interfaces. First of all, on the next slide, we will take a look at the sensor technologies that are used in such smart devices, as we can see here. We have, for example, a Hoover robot here on the top left side, which is also going to be our case study later, or a lawn mowing robot, agricultural machinery on the bottom left side, and also cars here on the bottom right side. And those modern products are more and more using sensors because they're moving around in a three-dimensional context, maybe also flying in the future, like drones and stuff. And more such technologies like GPS sensors, like all those sensors here on the right side, especially in the automotive industry, we have a lot of radar, LiDAR, or camera sensors, are getting into those products, and we need to write software so they are working together with all the other software and hardware components in these products. And the validation of such products is of course not as easy because there are a lot of different errors that might occur. And now we want to take a look how we can do validation for such sensor technologies, but also of course for the whole system in which they are used. And of course for the HMIs or so-called human machine interfaces, displays, and so on, that are used to control such new products. And for this area, I want to hand over to Sören from Testbirds.
Thank you. Yeah, so all of these aforementioned products are, of course, also somewhat related to smartphones or handheld devices in general. So as you can see at the top left corner, there are, for example, smart locks that have an app where it's important to make sure that the connection works properly, but also to make sure that the app itself has a trustworthy design and feeling towards the user. And when we think about other smart products, such a thermostat here, the interface is quite unique and needs special care. The HMIs mentioned by Alex before, in this case it's a Model S, have also like a very unique kind of design and user interface, especially when it comes to the connection to a smartphone. When we look at Android in this example, there is a huge device diversity involved, and of course also the environments matter. If I'm standing right next to the car, the connection will be much better. If you're familiar with German mobile data connection, then you know if you're out there in the forest and want to remote control it, it's a different story, because you need good mobile connection to get access to your car. But luckily, there is a V model 2.0 that can solve basically the testing for both worlds, which Basti is going to present on the next slide.
Yes, thank you very much, and welcome also from my side. I would explain to you in a short manner what is the V model 2.0 about. So as you can see, the well-known V model on the left, and on the right, it's the testing pyramid from Michael Cohn, which is nice. And we can both companies, we can combine these both methods. So we start in the left upper side. So in this area, we can help you with a lot of knowledge and experience from further projects. And we can give you some consulting technologies or something like this, how you can design your product, how you can design your tests, how would you design the interfaces for debugging interfaces, or how you can design your hardware and software and architecture and all the stuff. And right in the bottom of the V model, you're starting to develop software. For sure, Magna Telemotive can help you here with a lot of knowledge. And then now the pyramid on the right side comes into play. If you are developing software, you should always develop unit tests. So that's the reason unit tests are the most available tests in your development phase. And then we go up to each step of the V model, up to end-to-end tests. So in between, we have service tests, which means when you are getting out of a software function, then you can start to combine components. You can start to combine functions and maybe hardware components. So you need another kind of tests here. That is the service test layer about. And you need other tools as in the unit test area. And then you're going further to UI tests, maybe like you testing something on a screen or a smartphone or an HMI, as Alex mentioned before, and CERN also. And then the crowd testing part comes into play. You should combine both. So combine automated test cases and combine the crowd testing as early as possible. Not only experience in your left branch of the V model, in the requirements area, also combine it with testing. And if you're not able to automate it, you should try to go to the crowd testing stuff. So that's the combination of the V model 2.0, the combination of two methods. Also, continuous integration is involved here. So for each change in the software, you should go through the whole process of the automation test, regression tests, and the crowd testing. So it's a nice and smooth combination of both methods and also a knowledge of both companies that are working greatly together here. So now I will hand over to Alex. He will start the case study, right?
Yes, thanks, Basti. So what we want to look at today in our case study is how we can do a validation for a Hoover robot. As you can imagine, a Hoover robot going around in your house, cleaning the floor and so on, has different sensor technology involved. And how can we, as a company, maybe we can imagine that we are a new company called HooverBot, how can we build a new generation of Hoover robots? So for this case study, we imagined that our first generation of Hoover robots had still some issues. Like you can see on the video, the Hoover is stuck in the carpet and it cannot move anymore. And also we want to add new features, like here on the top right corner, we see a Hoover robot that can identify, maybe with a LiDAR detection or something, he can identify stairs and he does not fall down the stairs and break, but he just turns around and goes across the whole room. And at the top right corner, we can see a Hoover that is going through the room in a certain pattern. And those are two new features that we want to implement, plus a control for the HMI with a mobile app. And this way we want to build a second generation of our Hoover bot that is superior to the first one, that uses new sensor technology. And yeah, so that's the Hoover robot case study that we want to present today. And on the next slide, Søren will explain what implications this has for the HMI and how it's controlled by the mobile app.
Yeah, what Alex mentioned before is that because of the early generation stages, also the UI, so the app, were a bit more limited in the scope of functionality. And we see nowadays that the new versions offer much better possibilities to, for example, schedule cleaning. You can track the live progress, or you can get remote access if your kids, for example, spilled some dry muesli on the floor and they text you and don't know what to do. You can basically trigger a new cleaning process, which wasn't the case before. However, with these new capabilities, also the traditional UX testing methods are less suitable. If you were to picture, for example, a traditional UX lab where people come for a lab study for, let's say, 90 minutes, like a scheduled cleaning or remote access can't be tested in a real way, because a person would need to be at work or just have it scheduled over a longer period of time, where the traditional methods are a bit more limited, and where Magna and Testbirds came up with a very, very good approach to make sure that the sensors and also the app and the user experience are in a very good state. And as we knew that Magna is going to cover the sensor testing, the crowd testing could very much focus on the interaction between the app and the Hoover robot and the connected user experience by a user. And on the next slide, Basti, Alex, as a matter of fact, is going to talk a bit more about the split between Magna and Testbirds.
Yes, I think Basti could explain it very well as well, but we need him for the technical stuff later. All right, so this is our validation approach here in our automated testing combined with the crowd testing of Testbirds. So all in all, we have to say that a usual testing process involves manual testing, test automation, and as we still have here the crowd testing as well. On the left side here, we have this test automation that we want to set up for our validation toolchain. We want to do at the very early beginning of the development already a test automation setup that we can connect in a continuous integration environment. That means we start already from the beginning when the first components are coming in. Maybe some components are bought by other manufacturers, like a sensor is bought from a third party, another sensor from a third party, maybe a motor is bought from a third party or an engine. And then an ECU, so a control unit, is built for this Hoover robot, and it contains the whole software for the Hoover. And we set up a test automation toolchain in the beginning that is doing system testing and subsystem testing. System testing in the end is running for the complete Hoover robot, of course, but subsystems are, for example, one subsystem is the sensor, one subsystem is the ECU, and so on. And we test the different subsystems before we test the complete systems. And of course, we do some connectivity validation in an automated fashion to make sure that generally you can connect a smartphone. And as soon as this works, we continue with crowd testing. and we bring the Testbirds into our testing process. Why do we do this? Because they have their crowd testing approach, about which Søren will talk later a little bit more in detail. And this crowd testing approach will mostly be used to test the UX and UI design by pulling real people and real users into the testing process, and also check this large device diversity on mobile phones so that any Android device, for example, is working together with our Hoover robot and that everything works out fine. Of course, additionally to automated testing and end-to-end crowd testing, we need to do some manual testing. This is always done in the background, and this case study here is focusing on putting especially the test automation, the crowd testing here in the front. But of course, there's always some manual things that you cannot test in an automated way, or maybe also not with crowd testing, which have to be done additionally. Just to say that in case people are thinking everything can be done just by automation and crowd testing. There has to be at least a little bit of manual testing as well. What you can see here on this slide is basically 5 points or bullet points about the test automation and benefits of a test automation setup where we have a full system and can also do subsystem tests. The first benefit of a test automation toolchain, which is in this case done with Telemotive Test Automation, our Python framework for test automation, is that we have a component test bench that we build up. We did this for several projects already, and it's a really good thing. You have to imagine this Hoover robot that we have, and it's split into its separate parts. For example, the wheels that are turning around and driving the Hoover, and also the Hoover mechanism to get all the dirt cleaned, and also the ECU. So those parts are assembled in one component test bench, and the components are connected as they are in the Hoover robot. So we can test every single component, but also can test the complete Hoover. And for this test setup, we do, as here the second bullet point, automated tests in a continuous regression testing. That means whenever there's a new software update, we write test cases in a way that they are automated already in Python. And whenever there's a new software update, you can do a regression test for everything that you already have written. For every test case that already has been written, can just be executed with one click in the Python framework. The third bullet point is the compliance of this testing to the ISTQB standard. This is always a really important point for us to ensure that there's a high quality in our testing. And the ISTQB is a software testing foundation that certifies software testing and gives out such certificates. So the fourth one here, a real big benefit of test automation system is that we can find errors really early in the stages of the development. And this is also the goal why we do this test automation. So we start really with the development progress. As soon as the first component comes in or is finished, we already start automating here the test cases so that all those tests that are failing have test results or test reports that can be given back to the development department. And then the development department can implement the software in a way that it works in the end, that those errors do not happen anymore. Last of the point is that we do this automation really in a continuous way. As I already said in the beginning, whenever there's a new update, new software coming in, maybe an update of the component and so on, we just run all the tests that we already have in a regression testing. And this way we make sure in our projects that we have a really high quality of the product in the end of the day. So this was the key benefits of the automated test system. And now I want to hand over again to Søren, who will explain the key benefits of the crowd testing that comes afterwards.
Yeah, thank you. So from on this slide, you can see 4 key benefits. And the first one being that if you are a developer or a designer of your own product, usually there is some sort of organizational blindness involved when it comes to testing, because you know how a user is expected to use a product, but in the end, the user might have a very different user journey when they open the app for the first time. And by involving real people from our crowd into the testing process, this organizational blindness or bias can be circumvented. And it's closely tied to the second key benefit, which is the target group relevance. If you want to roll out products, it's always important to involve people from your real target group into the testing, because they might have a very different scope of requirements for your product. Let's say if it's 50-year or older people mainly using your product, the requirements might be very different to millennials using the product, where a product is probably more shiny and a bit different when it comes to design. And with a crowd testing setup, you can make sure to actually target your user group to involve them. What is important about these target groups is that the third point or the third key benefit is that they bring their own devices to the testing. So you can make sure that you can involve the vast majority of iOS devices and Android devices into the testing. Especially if you think about the new, I don't know, for example, the iPhone 12 that just being announced yesterday. With our crowd, we have a lot of very active users, for example, that are very keen to get new devices, but also keep old devices in their drawer, literally. So we can make sure that we can benefit from this device diversity. And the fourth key advantage is that we can evolve real-world environments. If you think about the Hoverbot, the environment is actually very important. You need to make sure that you cover different surfaces. You've seen the rug before. The video of the rug is actually 3 minutes long. So if you want to get the full version of a Hoverbot struggling to get over a rug for 3 minutes, let us know. But this was a real issue in the past. And also you need to think about furniture. Does somebody have like chairs or tables in their environment, or family situations such as kids or pets? You might have seen videos in the past of dogs leaving surprises in the living room and the Hoverbot not handling them very well, let's put it like that. These are something you can test with real world environments, but not in a UX lab. And we could make sure that in such sort of setting, depending on the development phases, we can make sure to support appropriately. And when we look at the next slide, we can see a development process. And of course, any development starts with a concept phase where you think about, okay, what do we want to achieve? What do we have already? What information do we have about users and user behavior already? And in this concept phase, it often makes sense to start with some interview setting where current users of your product are interviewed to understand what should we improve on in the next generation of the product. And these learnings can then be implemented into a first prototype where we ran a prototype evaluation to give users the chance to take a look at a click dummy prototype via Envision in this case, to give feedback. It's important to make these kind of testing prior to actually developing them, because you might end up with very valuable feedback. And if you start developing the actual application prior to the testing, you might run into like a wrong direction and then need to change the requirements, the user stories of the application, which can result in some sort of wasted resources. The third phase of the development process is the development phase. So you actually start with the first alpha features. And in this kind of setting, we can support with technical exploratory bug testing. So it doesn't need to be the entire app being finished already. So no beta version is required, but you can already start with some testing on various different devices to make sure that you can get the testing done prior to the release and in time, and you can utilize the development phase for this kind of testing. And then this dedicated testing phase, the fourth one on this slide, is something where we deeply work together with Magna. And you're going to see it in the following slide afterwards, how the telemotive test automation part was conducted. What we supported with in this setting is if there was some testing required from one day to another, let's say it's Wednesday and they needed information by Thursday, end of business, we could support with this exploratory bug testing approach to make sure that we can also complement the automated part with the crowd. Last but not least is the fifth phase, so the release phase. You want to make sure that prior to actually releasing it, that you have a very in-depth testing of the Hoover bot in this case and the application. So what we do here is we send out, so we ship out actual Hoover bots and ask people to use it for over the course of 2 weeks to make sure that various different use cases can be covered. And also because different languages require different kind of testing, that we can make sure to send it out to different countries. When you think about Russian and English languages in comparison, the Russian language tends to be much longer. So it has some specialities, let's put it like that. So we want to make sure that also localization can be tested prior to the release. And this is, of course, an iterative process, and you could start with the next generation from the beginning again, which we're probably going to see in the next couple of years. Or in this case study, let's take a look at the telemotive test automation setup.
Yes, thank you, Sören. So I tried to explain you now the test setup we achieved here. So let's start on the left side. So the green box is a disassembled robot, and we mount it on a test bench. So that's the frame, the hardware frame in it. And we tried to achieve a setup that we can access to each component. So what we are showing here on the slide. So we have our PC with a TDA on it, also the telemotive test automation. And we are connected to a simulation board with a pipe interface. So we can easily control the simulation board, and the simulation board can control the LiDAR and camera sensor. It's nice. So we can check if all sensors working properly. So we can send in some data frames inside the LiDAR sensors and the camera sensors, and we can check what will happen in the Hoover ECU and what the Hoover ECU is going to be and to do. So furthermore, we are connected to the Hoover ECU. So this is the main ECU in the robot, and we have a nice interface here. So we did a good work in the design for test phase. So we designed a lot of good interfaces, also a diagnostic interface to the ECU. So we can do diagnostic sessions on the Hoover ECU, and we can send requests, and we get responses from several sensors, and also from the engine and from the Hoover mechanics and all the stuff. So we can control them, and we can do this on a automatic way. So it's nice. We also can control the Hoover HMI over diagnostic sessions. So we can press buttons, or we can do a swipe or something like this, but we cannot do any, let's say, quality measurements here like the crowd can do. So that's the mention here on the right. So that the crowd can test how the HMIs look like, and they can get feedback on this. So that is a test, and that is the information that only a human can provide, and not a machine really. So we have a nice connections to the setup. So we are connected to the ECU, we are connected to the robot, we can simulate the robot, and now we can perform tests. Furthermore, we have a little connection to the mobile devices, so we can do basic tests on the mobile devices. It's more easy on the Android side than on the OS side and the iOS side. So we can run some tests here, and also here the crowd from Testbirds able to do the complete testing for the mobile devices. So that's the setup we achieved here. And the next slide, when we go to the next slide, we see the outcome of the automation. I want to explain to you. So we could disassemble a robot and assemble them on a test setup, on a test bench, and the test bench is controllable with our PC, where TDA is installed on it. And our sensors can be controlled, and the touch display can be controlled via diagnostic sessions. So it's nice. We can start regression tests. We can also include them into the continuous integration testing. So we have a complete test setup within the continuous integration platform, which is very great. And we also have the opportunity, if a technical guy or tester comes to the test setup, he can do semi-automated tests. He can send frames into the sensors, or he can do a queue of diagnostic sessions, all the stuff, and can see what is the robot going to do. And for this, or with this setup, we are able to achieve a test automation level for 70%, which is really high, which is nice. As I also mentioned, is that we have a mobile app automation. So we can do some rough tests. We can open the app. We can check if it's installed and all the stuff. But for sure, we handed over the test over to the Testbirds, and especially for the iOS tests, the crowd from the Testbirds bring a lot of good results here. So I will hand over back to Søren to check what is the outcome of the crowd testing.
Yeah, thank you. So to give you a little bit of an overview, what we've done for the end-to-end testing prior to the release, what we've done is that we recruited 30 testers from our existing crowd and made sure that about half of them were users of the previous generation of the Hoover robots, and the other half was new users, or users who hadn't used that specific brand. Because of course it was important to cover both target groups. Existing users might already know some shortcuts from the previous version, or they are used to specific features that have changed or might not have been implemented into the newer generation, while new users are just, yeah, it's a green meadow for them. They are not biased, they don't have experience, but for example, onboarding processes work very differently for new users. If a person just doesn't know how to use it in the first place, he will have very interesting user journeys, that put it like that. We made sure that based on the discussions that we have with Magna and Hoover to come up with a good mix of devices. We knew that Android was very well tested already, but there was some emphasis needed on iOS devices because of the specific setup. What we've also done is to discuss with Hooverbot what devices they have internally, because we want to make sure that when we come up with a device mix, we don't have an overlap of existing devices, but maximize the value in that sense. And during the recruitment, we also put a special emphasis on the environments, as I mentioned before. So we can make sure that we have different furniture types, different rugs and carpets, but also pets involved to also cover such use cases. And I think there was already a question in that regard that we're going to respond to later. And what we've seen as an outcome is that actually the new generations, mainly also because of the great testing done by Magna, handle rugs and moving objects, so pets and potentially kids, much better than previous generations. We've also seen less Hoover bots falling down stairs, which is something that we also tested. So there were great results in that sense. And what we've also seen is that the overall usability has increased a lot. The user experience was a lot better. So people were much happier with the product from unpacking it to actually using it over the course of 2 weeks, which is where user experience is basically generated. Of course, no app is perfect. In the final end-to-end testing, we were able to still uncover 43 reported bugs. There were a lot of issues with localization still, but only 3 of them were critical or very critical in that sense, which caused the app to crash, but could luckily be fixed prior to the release. And then to wrap it up, we want to say a few words about what the key benefits were on the next slide. And I think what stuck out the most from my perspective, and I think Basti and Alex going to say a few words about that as well, is really the holistic testing approach, that we could make sure that the functionality, connectivity, and UI were tested properly, and that the mobile app and UX in combination with the hoverbot were tested so thoroughly. And it really surprised me how much of a difference the system testing on the test bench really made. And I think Basti and Alex can say a few words about what really stuck out for them.
Yes, so from our side, of course, it's always good to work together with professionals. And as the German word already says, yes, so from our experience working together with the Testbirds was really nice, because now we are able, with the Testbirds Nest especially, so the software where you have all those crowd testers, where you can tell them, you can check who of those testers has which product or which version of the product, and give them different test cases and tell them, what do you think of this, what do you think of that. And that was something that we were really never capable of doing. We were always really on the technical level, focusing together with the customer on finding technical issues, technical errors, just working in the laboratory. But going out of the laboratory, going to real customers and getting feedback from customers that use this product at home, that have a mobile phone, try to connect it and try to let it run, even by bringing our own testers into that crowd. But once you have different homes, different rooms that the robots have to clean, there are so many different other obstacles that are coming into. And when you just test the robot in one laboratory, then of course it's a totally different thing than if you have a whole crowd that you can work together with. So that was really the benefit from our side, working together with the Testbirds, that this software, so the Testbirds Nest, worked so well in all the features and what it can do, and identifying the right users, and then combining this with our laboratory testing and seeing if and maybe also checking if something that didn't work in a laboratory is also not working for the customers at home, or how critical some errors are. That was really some things where we want to push this cooperation together with Testbirds, and where we would say, when we set up our next projects, this is always a really good combination for us, and something that we also tell the customer, of course, from our side, he might consider.
Yeah, I also want to add a big advantage and also a big help. I really like it. It's a big database, the Nest from Testbirds, and the combination of the crowd tests and test results from the automatic test runs and also from the crowd. That's a really, really huge advantage. Yeah, really liked it.
All right. So I think, as this is already the wrap.
Thank you for joining and listening again. And it was my pleasure to talk to you all.
Thank you for hosting here.
Thank you too. And I wish you all a great evening.